Today, we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry. Mole concept, come on, let us discuss few more questions from this session. Here, in this point, here, if the volume of a drop of water is 0.0018 ml, then the number of water molecules present in 2 drops of water at room temperature. This is very simple and interesting also and important also. So while looking at such kind of questions, 3 steps you have to follow to find the answer. So what are the 3 main steps? First and foremost, you have to identify the mass of water. Mass of water. That is the 2 drops of water they mentioned, so find out the 2 drops of water. So mass of 2 drops of water, because mass if you identify only, you will come to know the second step, number of moles of water, number of moles of water, and then third one, if you find this only, you will come to know that number of molecules. They mentioned what it is, water molecules, number of water molecules. Then only you can identify number of moles of water. If you find only, you can find out that number of molecules of water. So whenever you're solving that sum, you should come to know that how to analyze the question. That means how to find the answer according to the stepwise. So it will be easy for you to solve the problem. Okay, now what it is, volume of water, that is 1 drop of water. So we can mention it as a volume of water. So first and foremost, we will write the data so that easy to apply for it. Okay, now volume of water, how much it is? 0.0018 ml. So 2 drops of volume of 1 drop of water, it is 0.0018 ml. Now 2 drops of water, 2 drops of water. So that is volume of 2 drops of water. How much it will be? 2 into 0.0018 ml equal to 0.0036 ml. Got it? Now that is a 2 drops of water. Now we want mass of 2 drops of water. Generally, when we go to find the mass, density formula we can utilize. Density usually mass by volume, right? So here 2 drops, mass of 2 drops of water, mass of 2 drops of water, mass of 2 drops of water equal to 0.0036 ml into what it is. That is actually mass by volume. It is 1 gram per ml only, for water density. So into 1 gram per ml. So this ml and this ml will be cancelled. So that means here what it is, 0.0036 into 1 gram. So that means 0.0036 gram. Because mass they mentioned, it's gram only, remaining gram, right? So mass of 2 drops of water we found. This is 0.0036 gram. Yes, fine. Now we have to find out that number of moles. It will be easy. Number of moles equal to given mass by molecular mass. This is the given mass. Okay. So number of moles equal to given mass by molecular mass. Molecular mass. Right, I just mentioned molecular mass, same only. So here number of moles of water I just mentioned. So here 0.0036 gram divided by water formula. What it is? Molecules of water. What is the mass of molecules of water? Here 18 gram per mole. Right. So here what it is? Gram and gram will be cancelled. So what is the answer here? You will get here 18, here 36. So 0.002 mole. Right. So number of moles of water is, this is the answer. So number of moles also we found. Now finally we are coming to that number of molecules. See, step by step it will be really easy to identify the answer, and it will be interesting also, like one by one you will go. Number of molecules, number of molecules of water. So we mentioned in that according to the question. So number of molecules here, moles into Avogadro number. This is the formula. So number of molecules whenever we are finding for it, any of it, that is moles into Avogadro number. Moles, just now we found what it is, 0.002 moles into Avogadro number, how much? 6.023 into 10 to the power of 23. Here what it is, mole per molecule. Mole per molecule. Right, so mole per molecule. So this mole and this mole will be cancelled. Okay, this moles and this moles will be cancelled. So when you calculate these both, you will get what it is, 1.20, right, 1.2044 into 10 to the power of 20 molecules. See, this is both, you are multiplying only mole per molecule, that is a unit. So here, so that you will get 20, you will be getting, right? Now, we can write. So we can write. How can you write it? That is 12.044 into 10 to the power of 19 molecules. What is the answer? This is 2 drops of water molecules. That is equal to 12.044 into 10 to the power of 20. Sorry, 10 to the power of 19 molecules. Hope you got that idea how to solve this step by step. I hope you got that idea how to solve. Yes, come on. Let us go to the next question. So which is the correct option? Option A is the correct option, right? So this is the correct option. Yes, come on. Let us go to the next question. It is known that atom contains proton, neutrons, and electrons. If the mass of neutron is assumed to have half of its original value, whereas that proton is assumed to be twice of its original value, then atomic mass, that is 6 carbon 14, will be right. Now here in this point, here I just mentioned each data so that it will be easy for us to identify the answer. Now mass of neutron. So here mass of neutron, how much? Half of its original value. Half of its original value. Right. Second one, what it is? Mass of proton. Mass of proton, how much? Twice of its original. Twice of its original value. Right. Now, here, atomic mass, what they mentioned, 6 carbon 14. Atomic mass, it is 6 carbon 14. Now here, this is atomic number. That is what it is, number of protons, only atomic number. And this is what it is, mass number. This is mass number. And this is protons plus neutrons, mass number. Now this is an element. Now here very easily we can identify. So in this point, here what they mentioned, number of protons, it is actually 6. Number of neutrons, actually, how do we identify? Mass number means protons plus neutron, right? So that means here 14 minus 6, you will get what it is, 8. So number of neutrons, it is 8. Now let us identify that new value over here. So mass of proton, what it is? Mass of proton, that is twice of its original value. Mass of proton, it is 6. Twice of its original value 2. So you will get 12. So number of proton, that is mass of proton, it is 12. And mass of neutron, what it is? Mass of neutron. So mass of neutron, it is actually 8. And what they mentioned, half of its original. So into half of its original. So the answer you are getting 8 in that half of its original. So you will get 4, right? So mass of neutron, it is 4. Mass of proton, it is 12. So now total, what it is? Atomic mass. Total, it is actually what it is? 12 plus 4. So total mass, proton plus neutron, right? Total mass. Total atomic mass. Atomic mass. It is actually 16, right? AMU. Right now they are asking in the percentage way. So how to deal this point here, percentage way? So percentage, here what they mentioned, it is percentage change, right? So percentage change means percentage, right here 16 minus 14 divided by 14, right? In the question, how they are mentioning about, that is the way, into 100. Percentage means into 100, right? So that means you will get what it is, you will get here 2, that is 2 by 14 into 100. So you will get what it is, 14.28%. Okay, so in this here, increasing or decreasing, they are asking. So 14.28, actually it is increasing only, it is not decreasing. It is not the same also. So atomic mass actually 6 carbon 14 only. No, generally here what the question they have given, 6 carbon 14. So mass of proton, it is half of its original value. Mass of neutron, it is half of that value. Mass of proton, it is twice of it, that value. So what is the atomic mass, whether it is increasing or decreasing? So naturally it is increasing. Why? Because it is atomic mass, how much it is increased? Is 16, it is increased. So naturally it is increased by, that is new minus old divided by that old into 1000. Percentage 100, right? Sometimes. Oh yeah, come on. So how much it is? 14.28%, which is increased. I hope you got the clarity about this question. 14.28% increased, right? Okay, so this is like number of proton, number of neutron. That question only, no, easy to identify. So this is like puzzle question and interesting also. Sometimes they may ask such kind of question also. You be aware that what is the correct concept, so that it will be easy for you to analyze the question. Now, which is the correct option? Option Here the option it is 14.28% more. So option C is the correct option, right? Hope you got the clarity. Come on, let's go to the next question. Common salt obtained from seawater contains 8.775% sodium chloride by mass, right? Okay, next, the number of formula units of sodium chloride present in 25 gram of this salt. Right now here, what it is, something different way they are asking that question, but actually the same point only. First and foremost, they have given the percentage wise that mass of sodium chloride. Now we have to find out the mass of sodium chloride. That means given mass, right? So first step, you have to find out that mass of sodium chloride, right? Second point, number of moles. Number of moles. Third point, it is formula units. Formula units, it is nothing. Same number of molecules only, but here they are asking in a different way. That's all, right? Formula units, it's nothing. Number of molecules to identify. Okay, I hope you got the clarity. Okay, now number of formula unit. Formula units. Right, come on, let us discuss all these three steps. The first one, so here percentage wise they have given, no? Okay, mass of the salt, right? I just mentioned here mass of the salt, mass of sodium chloride salt, right? So what they mentioned here, 8.775 divided by what it is, 100, right? Into, they are mentioning about 25 grams. So that means here 25 grams, here percentage. Right now you will get this, what it is, 2.19375 gram, right? You are getting, so this is a given mass, okay? So mass of sodium chloride salt only, this is given mass, this much. Okay, now given mass, if you know, means you are able to identify that what it is, number of moles. The second step, number of moles. That's what I just mentioned, what it is, step by step. Okay, now here number of moles of NaCl only. Given mass by molecular mass, given mass by molecular mass. So given mass, what it is, 2.19375 gram, and the molecular mass of sodium chloride, it is 58.5 gram per mole. I hope you got that. Okay, now what is the answer you will be getting when you calculate it? You will be getting around moles. This is number of moles. It is actually 0.0375 mole only. Why? Because this gram and gram will be cancelled, right? Okay, so number of moles you found, and now we are going to see that number of molecules, and this number of molecules is what it is, moles into Avogadro number. The formula units also the same representation, right? So number of formula units. See, usually sometimes they will give the twisting way. So indirect way they will be asking, but you know very well, right? You should know all the 360-degree level of thinking idea. So that concept, it will be same point only. Right now here, moles into Avogadro number. So moles, how much is 0.0375 moles into Avogadro number 6.023 into 10 to the power of 23 moles per molecules, moles per formula unit. Moles per formula unit, because they are mentioning now, right here, moles, this point 0.0375 moles. Right now this moles and this moles will be cancelled, so you will be getting the answer how much. So when you are calculating this, so you will get 2.258 into 10 to the power of 22 formula units. Moles cancel, no, that is formula unit. Right now here, number of formula units, this only. So this is the answer. Hope you got that idea. How do we analyze this question? Same like first question only. First question we have gone through now in this session starting. The same idea, mass of that substance, number of moles, number of molecules. So that is the way only. Here formula units they mention. So which is the correct option? Option here in this point here, 2.258 into 10 to the power of 22 formula units. B is the correct option. Hope you got the clarity. Right, come on, let's go to the next question. The number of hydrogen atoms present in 25.6 gram of sucrose, that is C12H22O11, which has a molar mass of 342.3 gram. Right now here, number of hydrogen atoms present in so and so gram of sucrose. This is also very simple, right? Here the same idea we can bring, but mass they have given, so directly we can go for what it is, number of moles. So number of moles equal to given mass by molecular mass, molar mass, right? So here given mass how much? Here 25.6 gram, right? Molar mass here they mentioned 342. Okay, so 342 342.2 gram per mole. Molar mass means that only. So gram will be cancelled. So the answer, it is actually what it is, 0.07479 mole. Right. So number of moles of sucrose. Right. So this is the answer. Right. Now the next point, what it is, number of hydrogen atom present in the sucrose. Moles of hydrogen, right? Number of moles of hydrogen atom, right? Moles of atom present in sucrose. So how many it is there? Actually, what is the formula? C12H22O11. So that means here 22 hydrogen atoms present over there. So 22 hydrogen atoms present in 1 mole of sucrose, right? 22 hydrogen atoms. 22 hydrogen atoms present in 1 mole of sucrose. 1 mole of sucrose. Right now, here, easy to identify now. Right, moles of hydrogen atom. So moles of hydrogen atom, how do we calculate it? Here, moles into number of atoms of hydrogen. Okay, so moles of hydrogen atom. Moles of hydrogen atoms. So moles of hydrogen atom, how do we calculate it? Here, commonly we got moles, common, right? So given mass by molecular mass. From that, here, you just take that moles into number of hydrogen atoms. Number of hydrogen atoms. Because in that one basket, apples also it's available, oranges also available. In that apple, how many apples are there? So for that complete what it is, mass or complete numbers, then minus this one. So in that way, like, so here moles into number of atoms. So in that way, so moles how much? Here 0.07479, right? Yeah, 0.7479 into number of atoms of hydrogen, 22 hydrogen atoms. So you will get the answer here. How much you will get the answer? Here, moles of sucrose. I just mentioned moles of sucrose. Here, hydrogen atoms. So you will get the answer here. What it is? 1.6453 moles. So 1.6453 moles of hydrogen atoms. Right, you got it. Now, total number of hydrogen atoms. Right now, here, the main point. Total number of hydrogen atoms. So, without Avogadro number, this what it is, this process will not be completed. So, moles of hydrogen atom into moles of hydrogen atom into Avogadro number of atoms. Right now, here, what it is, atoms per mole. Right, so this is moles of hydrogen atom into Avogadro number of atoms per mole. So when you calculate these both, what is the value you are adding? So moles of hydrogen atom, how much? 1.6453 into Avogadro number 6.023 into 10 to the power of 23 atoms per mole. So you will get what it is. You will get here mole and mole will be cancelled. No, this mole and this mole will be cancelled. Then 9.908 into 10 to the power of 23 atoms. Right, so this is the answer. So total number of hydrogen atom, always we will calculate what it is, total, that is number of moles into Avogadro number. Right, I hope you got the clarity. So 9.908 into 10 to the power of 23 is the answer. Come on, let us check this answer. Okay, so 9.98. 9.908. Actually, here 9.908. So here they mentioned, yeah, 9.908 into 10 to the power of 23 only. So 8 has become 1. So that is what here, 9.91 into 10 to the power of 23. So the option, it is B. I hope you got the clarity of finding the answer, right? Option B is the correct option. Question, caffeine has a molecular mass that is actually 194. If it is contained 28.9% by mass of nitrogen, number of atoms of nitrogen in one molecule of caffeine. Okay, now it's really important question also. Right now, come on, let us check here. And that caffeine formula, caffeine formula here they did not mention. I'm mentioning here. C8H10 and nitrogen, that is N4O2. So this is a caffeine formula. Molecular mass of caffeine formula, 194 gram per mole. Right now here, nitrogen, how much it has contained? 28.9% it is contained. So the mass of nitrogen. So how much it is? 28.9 divided by 100 into 194. So this is the way. Okay. So you will get how much? The mass of nitrogen present in that caffeine compound. It is 56.066 AMU. AMU or gram per mole, anything. Right now, atomic mass of nitrogen. Atomic mass of nitrogen, you know very well. Atomic mass of nitrogen, 14. Right now, how can you identify here 14 AMU? Now here, how many number of nitrogen atoms you have to identify now? So number of nitrogen atoms. Number of nitrogen atoms equal to, that is AMU, that complete whole you found now. So mass of nitrogen. So this is mass of nitrogen divided by atomic mass of nitrogen. So mass of nitrogen in the compound, that is given mass, we can take it, right? So mass of nitrogen, how much? 56.066 divided by atomic mass, it is 14. Directly I'm just mentioning, but I've explained, you know, how to identify the formula. So that is complete. In that complete, you are getting the nitrogen mass. So that is what given mass. So we can mention here given mass. Okay, so you will get what it is, 4.0047. So 4.0047, it is number of atoms of nitrogen present in the molecule. So number of nitrogen atoms present in the molecule. Actually, this I have to write it here. So I have written here. So what is it? Actually, complete a whole number only we can take it here, 4. Right, 0.00. We don't need to consider that. So that is actually 4 atoms. Of course, this is correct only. How do we know this is 4? Correct, because in the formula only it is 4 only. It is available. You just to check it. So sometimes we can check also. We can solve this kind of question. Okay, I hope you got the clarity. How do we identify? From the percentage, we are getting that separate of what it is, nitrogen mass. Then from that atomic mass, given mass by molecular mass, in that way. Then finally you are finding the answer, right? I hope you got that idea to solve this question. Now, which is the correct option? Option A is the correct option, 4 only. So starting first line only, you will come to know the answer. This is for checking point. Not only the same one, even you may get some other different question, such kind of question like this. If you're getting also, you are able to solve. This idea helps you to solve. Right, come on, let's go to the next question. Check the next question. The density of water is 1 gram per ml. What is the volume occupied by 1 molecule of water? See, really it is a very simple question and important question also. Right now, the density of water here, how much it is? Density of water, right? Density of water. Density of water, it is 1 gram per ml, right? Now, generally density, how do we calculate it? Density equal to mass by volume. Right now, here in this question, volume occupied by 1 molecule of water. So here, volume occupied, volume is equal to mass by density. Density, right? How much it is? Here, molar mass of water, it is 18 gram divided by what it is? 1 gram per ml. That is density, mass by what it is? Density, mass by density, right? So here you will get gram will be cancelled. So you will get ml. So 18 ml. Right now 18 ml, you got that volume, right? 1 mole of water occupies 1 mole of water occupies 18 ml. Therefore, 1 mole of any substance contain 1 mole of any substance contain how much? Here, Avogadro number only. Avogadro number, what it is? 6.023 into 10 to the power of 23. Right. Now, here volume of 1 molecule. Volume of 1 molecule. Volume of 1 molecule, how much? Here 18 ml divided by 6.023 into 10 to the power of 23 molecules. Right, so here volume by Avogadro number. So volume of 1 molecule, it is given volume by Avogadro number in that way. Right now, what is the value you'll be getting? You'll be getting around what it is? 2.989 into 10 to the power of minus 23 when it goes up 23, right? ml. So right now, which is the here? What is the value you are getting? Here 2.989. But in the question, Yeah, I just bring that point for you to here. What it is, 2.88 they have given in the option. They have given 2.88. Actually, what is that correct value in that when we are solving? 2.989 into 10 to the power of minus 23 ml only. In the question when we are solving, this is only the answer we are getting, right? So this is the answer you are getting. But in the question they have given this. Anyway, we are bringing the answer. It is almost nearer to that, no? So we are bringing this answer only. So option D is the correct answer, but the value, it is this only. Come on, let's go to the next question. 25.0 mm into 40 mm piece of gold foil is 0.25 mm thickness. Density of gold is 19.32 gram per centimeter cube. How many gold atoms are there in the sheet? Right. Yeah, this is a very important question nowadays because gold rate it is very high. Okay, let us learn thoroughly this question at least. Right now here, to 25 millimeter, 40 millimeter, and thickness how much? 0.25 mm thickness, right? Length, width, and breadth. Length, width, and thickness. Let us go for it so that easily we can identify. Here they mentioned millimeter. We can convert into centimeter, right? Okay, length. Length how much? It is 25 0 millimeter, and then width. Width how much? It is 40 millimeter, and thickness. Thickness how much? 0.25 millimeters. See thickness how mild it is, right? So here conversion, here 2.5 centimeter, here 4, I just put it equal, right? 4.0 centimeter, here 0.025, already 0.525, here 0.025 centimeter. So centimeter, millimeter conversion and all you might have known very well, right? Okay, now the next point, what it is, volume we have to identify. So volume, what it is, how do we calculate it? Length into width into height, like thickness, right? So volume equal to length into width into thickness. So you will get 2.5 centimeter only, everything. 2.5 into 4 into 0.025, right? So you will get how much? When you calculate together, you will get 0.25 centimeter cube, because volume, no, centimeter, 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 so centimeter cube you will be getting. Right now, next one, mass of gold. In the question, what they have given, mass of gold. Mass of gold. That is given mass. Mass of gold, it is 19.32 gram per centimeter cube, right? So, but here the volume you have to calculate, no? So this given thickness into here what it is, here what is the answer if we got it? 0.25 centimeter cube. So when you calculate these two, you will get the answer what it is. Mass of the gold you will be getting how much it is. When you calculate these two, you will be getting 4.83 gram. So when you calculate all this volume of that sheet, okay, so this much complete gram per centimeter cube, no? So in that, how much gold it is available, mass of gold, it is 4.83 gram, you got it. Right now, number of moles you have to identify. Number of moles, what it is, this is given mass, right? So given mass by molecular mass of gold. So number of moles of gold, right? So number of moles of gold, it is how much it is given mass, how much it is? 4.83 gram divided by molar mass of gold, it is 197 gram per mole. Right now here gram will be cancelled. So your answer will be what it is? 0.02451. Okay, mole will be getting. So number of moles of gold, you got it. Now the next one, what it is? You have to find out that mass, no? Yeah, here you have to get it. Number of atoms. Mass you find, number of moles you find. Now here number of atoms. Number of atoms of gold. That is the question, no? Number of atoms of gold. So how to calculate the number of atoms of gold? So number of atoms of gold, it is actually what it is? Moles. Moles into number of atoms, how to identify moles into Avogadro number. That's all. So moles, how much here you have found just now? That is 0.02451 into Avogadro number 6.023 into 10 to the power of 23. Right. Atoms. So this is mole. This is mole per atom. Right now here the answer it is, mole and mole will be cancelled. So atoms only, so number of atoms of gold only they are asking. Right now here the answer it is 1.47 into 10 to the power of 22 atoms of gold in the thickness, length and width they have given us. So 1.47 into 10 to the power of 22 atoms. They are 23 now. When you calculate it, you will get such kind of things, right? I hope you got that idea. So which is the correct option? Option D, 1.47 into 10 to the power of 22, right? I hope you got the clarity. Now, which is the correct option? Option D is the correct option. Come on, let's go to the next question. Average molecular mass of air is 29. Then, assuming nitrogen and oxygen gases are there, which options are correct regarding composition of air? Here, 75% by mass of nitrogen, 75% by moles of nitrogen, 72.41% by mass of nitrogen. Here, we have to identify here mass of nitrogen, moles of nitrogen, and by mass of nitrogen. Here they have given something different. Right now, come on, it is actually a tricky question only. Come on, let us discuss. Here, average molar mass. Right now, I will write the data so that it will be easy for us to analyze the question. Right now, average molar mass, it is 29 gram per mole. Right now, here nitrogen, atomic mass of nitrogen, and molecular mass of nitrogen and molecular mass of oxygen, because here N2O2 they have given. No, so N2 molecular mass, it is 28 gram per mole. Right, oxygen O2, it is 32 gram per mole. Right now, here and assuming that what it isn't, nitrogen and oxygen gases are there. No, it is like what it is, composition of air. Composition of air means we can take the concept of mole fraction. Right, mole fraction, how do we follow? Okay, mole fraction. So we can take it in this way, because they have given what it is, average molar mass they have given. In that nitrogen mass and oxygen mass we know. So nitrogen mass we can take it as a X. So X we can take it what it is, nitrogen mole fraction. Mole fraction, right? Now, and the same way, 1 minus X we can take it oxygen mole fraction. Right, now we can calculate. This is very simple. So average molar mass equal to, here what it is, X into nitrogen molecular mass plus 1 minus X into oxygen molecular mass. Right, I hope you got that idea. Now, come on, let us apply the value. What is the value? It is average molar mass. It is 29 equal to, here X, that is X into 28 plus 1 minus X into 32. Right, so you will get what it is. Okay, come on, here 28X plus 32 into what it is, 1 minus X. No, so 32 minus, yeah, 32 minus 32X. 32 minus 32X. I just bring it. Okay, 32X. Right, now here X and X we can bring it in this way. So here what it is, here 29 minus 32 equal to what it is, 28X minus 32X. Right, now here you will get what it is, minus 3. This is what it is, minus 4X. So you will get X equal to, we just bring it, X equal to 3 by 4. So 3 by 4, it is actually mole fraction only. No, so we can bring the point moles only. So 3/4 means actually 75%. When we go for percentage wise, 75% of mole only, because here actually the question they mentioned mass. Mass will not be the correct option. Why? Because they assume that molecular mass only 29 gram of composition. The complete mass only how much? It is 29. Then how come it is possible 75% by mass? No, this will not be the correct option. 75% by moles of nitrogen? Yes, of course. Right now, let us check with that now. Discussion only. Let us go and identify. So mass of nitrogen. Okay, here mass of nitrogen here equal to 0.75 moles into 28 gram. Right, gram per mole. Right, so you will get what it is. What is the answer you will be getting? 21 gram. Right, now here mass of 1 mole of air. Okay, total mass of 1 mole of air. Okay, total mass of 1 mole of air. That is average mass. No, so average, I just mentioned average mass. Right, so average mass what it is, 29 gram. Right, now here gram per mole only. Right, now here this also gram per mole only. Mass, that is given mass of nitrogen. Okay, so mass percentage of nitrogen. Right, so that is 21 gram per mole. Right, divided by 29 gram per mole into 100. So you will be getting what it is. You will be getting 72.41%. 72, yes. Okay, so according to this, here actually mass, already I mentioned, Mass will not be the correct 75% by mass, because we are not they are not mentioning about mass. Nitrogen and oxygen atomic mass only, that is molecular mass only we have taken, and the composition of air when they are asking about, that is mole fraction through that. So moles only we found it is x and a1 minus x in that way. So naturally option 2, that is 75% by moles of nitrogen, yes, exactly, it is correct. And 72.41% by mass of nitrogen, yes, just now we found this mass of nitrogen, no, total mass in that given mass by molecular mass, in that way we average mass, average mass. So 72.41% just now we found. So that means second and third, it is the correct option. See, actually it is a tricky way only, but we should be thorough the concept. So both the second and third are correct. Option C and option 2 and option 3, it's correct, right? The C option, it is the correct option. Okay, I hope you got the clarity. Come on, let's go to the next question. Yes. Density of dry air containing only nitrogen and oxygen, same like last question, is 1.15 gram per liter at 740 mm of Hg. Here pressure they have given in that way. Actually here what it is, mm of Hg we can go for in pressure converted into atmospheric pressure, right? Okay, so and 300 Kelvin. Yes, what is the percentage composition of nitrogen by mass in the air? Here also mole fraction idea only we are going to utilize to solve this. See, very tricky question only. Come on, let us discuss this question. Okay, first and foremost, let us convert this point. Let us 740 mm of Hg we converted into ATM, right? Atmospheric pressure, ATM. Okay, pressure, it is actually 740 mm of Hg. Converted into atmospheric pressure. So atmospheric pressure, what it is? Pressure is equal to 740 mm of Hg. And normally what it is? 760, right? 760 mm of Hg, right? At atmospheric pressure. So you will get the answer 0.9737 atmospheric pressure. Right, atmospheric pressure. So this is the answer. So we got this one. Now the second point what we have to identify here, the ideal gas formula. So because they have given for what it is, temperature, they have given, no, so volume also they have given, right? So let us go for that ideal gas equation related to the density formula. Okay, ideal gas that is equivalent to what it is, density, density, that is rho, no, rho to molar mass, right? Okay, now here density rho equal to pressure into molecular mass divided by R into T. R, it is universal gas constant, T temperature. So we have to find out what it is, molar, average mass of molar only, right? Molar mass of average, right? Average molar mass. So rho into RT divided by P. Now P only we just now found pressure. Right now, each one I just mentioned here. Now density how much? Density how much? 1.15 gram per liter, right? Our universal gas constant how much? 0.0821 liter, right? I just mentioned that also. Atmospheric pressure per Kelvin and mole, right? Okay, now next one, what it is? Temperature. Temperature, it is 300 Kelvin. And pressure how much? Just now we found that is 0.9737 atmospheric pressure. So it will be easy to identify the answer. So what is the formula we are using here? This formula, PM by RT, no? Now molar average only, molar mass of average only we have to identify. So rho RT by P. So let us apply the value, all the data I just provided here. So we'll apply the value here, what it is, 1.15, that is gram per liter into RT, no, 0.081821 821 into 300 Kelvin, right? So that is the value I have given, right? 821, right? Okay, Kelvin divided by pressure how much? 0.9737. When you calculate all this, you will be getting around what it is, 29.09 gram per mole. Why I mentioned gram per mole? Because this is molar mass average only. Molar mass average only. Now percentage we have to identify. No, for that we have to depend on what it is, mole fraction. So mole fraction is equal to mole fraction. So mole fraction, as we consider nitrogen, we can take it x. Oxygen we can take it what it is, 1 minus x. Nitrogen molar mass, it is 28. Oxygen molar mass, it is 32. Gram per mole, everything gram per mole. Okay, now let us check here a molar average molar mass, right? Average molar mass equal to x into nitrogen plus 1 minus x into oxygen. Okay, let us apply the value. Here what it is, 28 into x plus what it is, 1 minus x into 32. Right. Now when we apply this is actually here what they have given 29 now, 29.09 gram per mole. That's what we have got that answer over here now. Yeah, 29.09, right? So here that means here 29.09 equal to here 28x plus 32 minus 32x, right? So you will get how much here? You will get the same idea, 4x equal to 29. So when you calculate this, no, 2.91 you will be getting, right? So x equal to 0.7275. So x equal to, it is 2.91 divided by 4, no? So 7271 you will be getting, right? So 7271, what it is? It is actually molar average. Now, molar mass of average, the mass of nitrogen in 1 mole of the air. Mass of nitrogen in 1 mole of the air. 1 mole of the air. So how to identify this is, so this we can go for nitrogen into x only. So this is actually x, we got it now. So x into 28. So here how do we identify that? So x equal to this, no? So mass percentage, total mass of 1 mole of air. Here mass percentage of nitrogen. Okay, so this is actually x into molecular mass of nitrogen divided by molar mass of average molar mass into 100 mass percentage. No, okay, so come on, let us apply the value here. X equal to how much? X equal to 0.7275 into 28. Nitrogen they are asking, no, that is what. If they are asking oxygen, you can apply that value of oxygen divided by 29.09 gram per mole, that is molar average mass into 100. So you will be getting around what it is, you'll be getting 70.02%. It is going around the neck. So mass percentage of nitrogen. See, actually it is really step by step if you go only easily, but mole fraction, it is that concept, it is same for last sum and this sum, but it is really interesting to solve. So which is the correct option? So say step by step we just go and analyze this. Okay, now which is the correct option? 70.02, right? Yeah, so option C is the correct option. Option C is the correct option. Come on, let us go to the next question. I hope you got the clarity of this question, right? A gaseous mixture of hydrogen and carbon dioxide gases contain 66 mass percentage of carbon dioxide. Vapor density of mixture is really, this is also a very important question. Come on, let us check that. Here mass percentage of carbon dioxide they mentioned. Okay, this is actually a mixture. Hydrogen and carbon dioxide gases contain 66 percentage of carbon dioxide. Okay, so sample mixture we can bring it that idea. The gaseous mixture or sample mixture. Okay, yeah, okay, sample mixture. Sample mixture, how much? Generally 100 gram. In that mass of carbon dioxide, how much it is? 66 gram. Right. Mass of hydrogen, how much? Mass of hydrogen. So from the total we can calculate it. So this is 100 gram minus 66 gram. So you will get what it is? 34 gram, right? Now number of moles we can identify. Anyway, it is percentage, means that is gram only, right? Okay, so number of moles. So number of moles equal to moles of carbon dioxide. Okay, moles of carbon dioxide. So that is given mass by molecular mass, no? So here what it is? 66 divided by 44. 44 what it is? Carbon dioxide. So you'll be getting around what it is? 1.5 mole you will be getting. Right, now this is what it is, number of moles of carbon dioxide. Now number of moles of hydrogen. Number of moles of hydrogen. So number of moles of hydrogen, how much? Here 34 divided by 2 gram per mole. This is also gram. This is gram and this is gram per mole. Okay, so units are very important. Gram and gram will be cancelled. So mole, here gram per mole. So here also gram and gram will be cancelled. So the answer it is, here you will be getting what it is? 17 moles. Right? So you are getting what it is? Hydrogen, number of moles of hydrogen, and carbon dioxide number of moles of, so total moles we can calculate it. Okay, total moles of hydrogen and carbon dioxide, total moles. So total moles of carbon dioxide and hydrogen. So how much it is? 1.5 plus 17. So you will be getting around 18.5 moles. Right. Okay. Now next one. Here they are mentioning about what it is. Average molar mass. Okay. Molar mass. Molar mass. Average molar mass. Now mass, that is average. I just mentioned it this way. So average molar mass, that is total mass divided by total moles. Total mass divided by total moles. So you will be getting molar mass. Okay, that is what it is. So here 100 gram divided by total moles, how much? 18.5 moles. So you'll be getting around 5.45 41 gram per mole. So you're getting this one. Right now here vapor density they are mentioning about. So this is actually molar mass. This is a molar mass, average molar mass. Here 5.41 gram per mole. Okay, now vapor density is equal to vapor density. Vapor density equal to what it is? Molar mass, that is average molar mass divided by 2. That is a formula, no? So what is that molar mass? Average molar mass, it is 5.41. Okay, so 5.41 divided by 2, you will be getting 2.7, right? So this is the answer. So vapor density, this is 2.7. I hope you got the clarity how to deal this question right now, which is the correct option, 2.7. Yes, we got it. So you know how to deal. This is like empirical formula and molecular formula, how to deal. That is such kind of a point. Here also the same idea, you can bring it like for main from that mixture, and then we have to deal this carbon dioxide and hydrogen in that way, right? 100 gram in that 66, 100 minus 66 in that way, right? I hope you got the clarity now. Option C is the correct option. Come on, let us go to the next question in our next video. So long, I think you have got some ideas to solve such kind of these problems. And thank you for watching. Thank you for spending a valuable time